Hi, in this video we're going to look at the topic of fractions. This is the first of the videos on fractions, and we're going to look at the topic of equivalence. That's fractions that are the same as each other but with different values at the top and the bottom of the fraction. This is a GCSE foundation topic and has been requested by my wonderful Year 10 group, so thank you for that. For more information, if you want to follow me on Twitter, you can do so at Mr_G_Walton, or you can follow our school account at Tupton Maths. Okay, in this video then we are going to look at the following things. We're going to look at simplifying, also known as cancelling down a fraction. And you'll have seen this before, but I want to make sure that we can do it effectively and not just in the way that maybe you've seen before. We're also going to look at creating, notice the spelling mistake here, we're going to look at creating equivalent fractions, and we're also going to look at ordering fractions. That's making them smallest to biggest or biggest to smallest, depending on what the question says. Okay, let's have a look at this first example then. So it says write this fraction in its simplest form. So the key word here is simplest form. This means cancelling this fraction down. Now, one of the first things that you will have learnt, and you'll have done this all the way through school, from primary school all the way up, is this idea of cancelling down. And you might be used to doing something like this, where you've got 4 over 8, and you say, well, I can half the top and half the bottom. Or when I can do it again, half the top, half the bottom. And that's all perfectly fine. We can do that. However, in this example, over here, we can see that we can't just half the top and half the bottom, but that doesn't mean we can't cancel it down. This idea of halving that we did over here is actually dividing the top and the bottom by the same thing. What we were doing here is dividing by 2. Dividing by 2. And the same again, dividing by 2. Dividing by 2. Now, I can't divide the fraction on the left hand side by 2, but is there another number that does go into 35 and into 45? And hopefully you're shouting out, yes there is, 5 does. So let's see, if I had 35 over 45 and I divided the top by 5 and I divided the bottom by 5, what do I get? Well, how many 5s go into 35? That's 7. How many 5s go into 45? 9. So writing this fraction, 35 over to 45, in a simplest form is 7 over 9. Now, how do I know that 7 over 9 is in its simplest form? And this is going to use another one of our keywords, and certainly when we're dealing with number topics, we're looking at prime numbers. I am convinced that this is in its simplest form because 7 is a prime number. Nothing else goes into 7 apart from 1 and 7, and neither of those go into 9 apart from 1. But if I divide 7 over 9 by 1, I just get 7 over 9 again. So that's not going to take me any further. Okay, so this is something you could always spot if you're looking at cancelling fractions down and deciding whether you've got to the simplest form. Look out for those prime numbers. In this next example then, we're going to have a go at completing the following equivalent fractions. So the first question says 3/5 is the same as something over 20. So what are we doing? Well, we are thinking, what can I times 5 by to get to 20? So if we times 5 by something, we get to 20, and whatever that is, we're going to do exactly the same to the top as well. Well, 5 times 4 is 20, so I must do the same to the top of my fraction to keep these things balanced. So 3 times 4 is 12. So an equivalent fraction of 3/5 is 12 over 20. What about this one? This is looking at the number on the bottom. You might have heard the number on the bottom being called the denominator before. I don't want to worry too much about what the technical terms are. If we deal with tops and bottoms, then I think you'll be confident doing that. Okay, so what can I times 7 by to get to 42? This is where your times tables are going to become really handy. 7 times 6 is 42. Now, something times by 6 gave me 54. And again, your times table is going to be really helpful here to know that that would be 9. Okay, so 7/9 is also 42 over 54. And this is funny because we had 7/9 last time, yet it was a different fraction. And there are lots of equivalent fractions. Okay, so 7/9 is the same as all kinds of different things. Excuse me. For example, 14 over 18. I've timesed top by 2 and bottom by 2. These things are equivalent, they are the same as each other. Let's have another thing. What else could I have done? Well, I could have timesed it by 3. 21 over 27. Also equivalent. All these things are equal to each other. And you'll see patterns between these numbers as well. So, for example, the last one that I've just written down, 21 over 27, you can see, hopefully quite quickly, how I could get from that to 42 over 54. I can times top number and bottom number by 2. Okay, so we're always doing the same thing to the top as the bottom. We're timesing by the same number. This is keeping it in proportion. It's keeping these things equivalent. Let's have a look at another example. This time we're going to look at ordering these fractions, starting with the smallest. Now, in order to do that, I'm going to suggest that what we do is make these fractions equivalent with the same number on the bottom. If we have the same number on the bottom, then we can just look at the numbers on the top and order those smallest to biggest. Now, in order to do that, we need to work out how we can convert these numbers to have the same number on the bottom. And it's called the lowest common multiple, or just any number that you are convinced 3, 4 and 12 all go into. It doesn't actually make any difference. The smaller numbers make it a little bit easier, but it really doesn't matter. If you can see a number they all go into, go for it. Okay, I'm going to turn all these into numbers over 12. I've spotted that 3 is a factor of 12. Notice I use that word factor, a number that goes into. So 3 goes into 12, so does 4, and so does 12. So 3 goes into 12, 4 goes into 12, 12 goes into 12. Let's see them. So 2/3 we're going to write to be something over 12. 3/4 I'm going to write to be something over 12. And 7/12 is already 7 over 12. So let's see. 3 times 4 is 12. Times by 4 here. To keep it balanced, I get 8 over 12. 4 times 3 is 12. 3 times 3 is also 9 over 12. And so now I can just compare the top numbers. I've got 7, 8 and 9. So if I was putting these smallest to largest, the smallest value is the 7, this one here. So 7/12 is the smallest. The next one is the one that was equivalent to 8/12. Now the question set out quite clearly, there was only one of these was in terms of 12. The next one was 2/3. So 8/12 is the same as 2/3. In my answer, I'm going to write down what it told me in the question, which was 2/3. And finally, 3/4, which was equivalent to 9 over 12 over here. So I'm not writing down the 8 over 12, the 9 over 12 and the 7 over 12 as my answer. I'm writing down what was in the question just in the right order. And I've used this idea of equivalence to help me. Right, here's 2 questions for you to have a go at by yourself. As ever, pause the video, read the question, have a go, and then play the video again to see the answers. The first question is asking you to circle or ring the fraction which is not equivalent to 3/5. And the second question is asking you to order them, starting with the smallest, these numbers here. Okay, so pause the video, have a go. Right, welcome back. So the first question said, which of these is not equivalent to 3/5? Well, let's take the first one. 6 over 10. Is there something I can do to 3/5 to get to 6 over 10? And I'm hoping you're saying yes. You can times the top by 2 and the bottom by 2. So 6 over 10 is equivalent. What about 15 over 25? What can I times 3 by to get to 15? Well, that's 5. 5 times 5 is also 25. So far, I'm happy that both of these two are equivalent. Let's look at the next one. Can I times 3 by something to get to 20? Well, not a whole number, no. I don't think that one's going to work so far. So this one is not equivalent. Before we move on, let's just check, because sometimes these questions have more than one answer. What can I times 3 by to get to 21? That's 7, and 7 5s are indeed 35, so that one works as well. So I've put a circle around the fraction which is not equivalent. Next, write these fractions in order, starting with the smallest. And also it says show how you decide. Well, we're going to use the idea of equivalence. What number do we think we could put at the bottom that 6 is a factor of, 5 is a factor of, 30 is a factor of, and 3 is a factor of? I'm hoping you've spotted 30. So 5/6 I want to put over 30. 3/5 I want to put over 30. And the same with the 2/3. I want to put over 30. So let's think. I can times 6 by 5 to get to 30. Do the same to the top. I get 25. I can times 5 by 6 to get to 30. 3 times 6 would give me 18. And the last one, 3 times 10, in this case, gives me 30. 2 times 10 would be 20. So now I'm comparing these. I've got, let's not forget this one here, I've got 17. So I've got, just looking at the numbers on the top, 17, 18, 20, and 25. So if I'm putting them in order, I'm just going to actually number them this time. 17 over 20 is the smallest. 17 over 30 is the smallest. 18 over 30 is the next smallest. That was 3/5. 20 over 30 is the next one. That was 2/3. And lastly was this one. They're now in order, smallest to biggest. If you got all those right, well done. You want to pat yourself on the back, because this is a fantastic opportunity to use these in a slightly different setting. You're also going to use these again on the next video that I'm going to do, which is all about fractions 2, where we're going to add and subtract them. So if you've mastered this topic, that's a really good stepping stone then to go on to the next topic, which is a grade C topic, looking at adding and subtracting fractions. As ever, in these videos, we do a revision card note section at the end, things that you might want to write down. In terms of the equivalent fractions, you might want to draw yourself some examples. You might want to say something like 2 over 3 is equal to, and then, I don't know, let's find a multiplier. Let's say we're going to times it by 4. You can do whatever you like here, as long as the numbers on the top of the bottom are the same. So we've said it's the same as 8 over 12. And you might want to pick another one as well. We've got enough space here. Why don't we multiply this time by 5, let's say. So multiply by 5, which is the same as 40 over 60. Okay, all these things are equivalent to each other. Excuse me. So cancelling fractions down. It's not just about halving the top and bottom. There's lots of things you can look for. Remember those questions that we did earlier on in the video where we divided the top and bottom by 5? Okay, so you can just looking for common factors, things that go into the top and bottom. As well as cancelling down, we can also scale fractions up, just like we've done over here. Equivalent means equal to. So all of these fractions are exactly the same as each other. They've just got different numbers, but their proportion, their ratio is the same. They have 2 out of 3 pieces here is the same as 8 out of 12 pieces, is the same as 40 out of 60 pieces. And when we're ordering fractions, make sure the numbers on the bottom are equivalent to each other, make sure the numbers on the bottom are the same, and then you just have to compare the tops. It's as easy as that. Okay, if you've got exams or tests coming up soon, good luck with them. Hopefully everything goes well. If you need anything, get in touch. Okay, thanks. Bye.